Today we're going to be reviewing the exponents work that you should know from last year. We're going to first start off by looking at the laws of exponents and reminding you about how they work. So the first law of exponents that you should know is for multiplying powers of the same base. Now just let me remind you quickly, a power is something that has a base and an exponent. So this thing together over here, this is called a power. And when I have powers that have the same base, so over here, a and a, they are the same. That means that when we multiply them together, we are going to add their exponents, and the base stays the same. So if I multiply powers of the same base, the base stays the same, and I add their exponents. Okay, the next one is for dividing powers with the same base. When we are dividing powers with the same base, we again keep the base the same, and we subtract the exponents. Okay, so when we're multiplying, we add the exponents. When we're dividing, we subtract the exponents, and in both cases the base remains the same. Okay, and it only works when you have the same base to start with. This can also be written like this. Remember that when you have a fraction, it means division. So this means a to the power of m divided by a to the power of n, which we can then simplify by saying a to the power of m minus n when we subtract the exponents. Okay, then we have raising a power to a power. When you're raising a power to a power, it looks like this, where you've got a power inside brackets with an exponent outside the brackets. And when we do that, what we're going to do is we're going to keep the base the same, and we're going to multiply the exponent inside and the exponent outside the brackets. So you end up with this, a to the power of m times n. Okay? And then if we are raising a product to a power, remember, a product is when you have things that are being multiplied together. So over here I've got a times b in brackets to the power of m. When you're raising a product to a power, it means that each part of that product, each factor, is going to get the exponent outside. Okay, so you have a times b to the power of m is the same as a to the power of m times b to the power of m. They both get that exponent. So any factors inside are all going to get the exponent outside. Okay, then we can also find the root of a power. When we find the root of a power, what we do is we take the power and we divide its exponent by the root index, which is this little number over here. Now remember, if you can't see the number, then the number is 2. So if there's no visible number there, it means it's the square root, and it's a little 2 that is invisible. Okay, so then you would divide by 2. Again, the base stays the same, it's not changing, so a stays a. So if this base is 2, it'll stay 2. If it is 3, it'll stay 3. If it's x, it'll stay x, and so on. But we divide the exponent inside by the root index. And then this can also be written like this, where you have a to the power of m over n, because remember, a fraction means division. So this means the same as m divided by n. Okay? Then we can also have zero exponents, where your actual exponent is a 0. And when your exponent is 0, then the power is equal to 1. The only time that this doesn't work is if your base is 0. You cannot have a 0 exponent when your base is 0. It doesn't work. Okay, so just be aware of that. But for any other base, then if you have something to the power of 0, it's equal to 1. Okay, so now let's go and have a look at our first example where we're going to be applying these laws. In this example, we need to simplify, leaving in exponential form if necessary. Okay, so the question we've got here is 3 to the power of 4 times 2 squared, all in brackets squared, times 2 cubed, and that is all over 3 to the power of 8 in brackets to the power of 0, and then the square root of 2 cubed times 3 to the power of 5 in brackets to the power of 4. Okay, so let's have a look at how we would do this question. Okay, so over here I've got my question. So there are two ways that we can do this in terms of the square root of here. So I'm going to show you two kind of methods that's just going to deal with that square root slightly differently. So everything else is going to be the same for both methods. It's just that square root that we can deal with slightly differently in two different ways. Okay, so first of all, what I need to do is I need to get rid of all the brackets, all the square roots, everything like that, so that I just have powers that I can then simplify my multiplication and division with. Okay, so first I've got over here brackets, and I've got inside the brackets 3 to the power of 4 times 2 squared, and outside the bracket that is squared. Okay, so I can get rid of these brackets by using the law for raising a power to a power and for raising a product to a power, combining those two. Remember, when we are raising a product to a power, we take each of the factors and we raise it to that power. So here I've got a factor, 3 to the power of 4, so I'm going to raise it to a power, but this factor is already a power. So I'm going to use the law for raising a power to a power for this factor, and then I'll do the same thing for that factor as well. Okay, so over here, 3 to the power of 4 squared. Our law is when we're raising a power to a power, the base stays the same, so the 3 is going to stay 3, and we're going to multiply the exponents, the one inside and the one outside. So I've got 4 times 2 is 8. Okay, so that's the 3 to the power of 4 sorted out. Now I'm going to go and do this 2 squared. The same thing is going to happen here. The base is going to stay the same, so it's still going to be 2. That doesn't change. And the exponent, I'm going to multiply by that exponent. So it's going to be 2 times 2 gives me 4. So that gives me 3 to the power of 8 times 2 to the power of 4. So that is what I got from those brackets over there. This 2 cubed, I'm not going to do anything with it at the moment. I can't simplify that. Then I've got, at the bottom of my fraction, 3 to the power of 8 to the power of 0. Now, 3 to the power of 8 to the power of 0, what I can do is I can do the same thing I did over here, where I multiply the exponents together. So actually, I'll show you both ways for this as well. I'll do the one way in the first step, or the first method, and I'll do the other way in the second method. So I can raise the 3 to the power of 8 to the power of 0 and say it's 3 to the power of 8 times 0 is 0. Okay, and then over here, inside the square root sign, I've got 2 cubed times 3 to the power of 5 to the power of 4. So I'm going to do the same thing over here with this set of brackets and that exponent. I'm going to raise the powers inside the brackets to the power outside. Okay, so over here, I'm going to have my square root of 2 cubed to the power of 4 is 2 to the power of 3 times 4 is 12. Remember, our base stays the same, so it doesn't change. It stays 2. And we multiply the exponent. So 3 times 4 is 12. Then over here, my base again is going to stay the same. I'm going to multiply my exponents. 5 times 4, that gives me 20. Okay, now I'm going to go and sort out this square root and that power of 0 as well. So over here, I'm not going to do anything with those for now. I could simplify that if I want to, but I don't need to. I can do it all in one step later. So I've got 3 to the power of 8 times 2 to the power of 4 times 2 to the power of 3. That is all over. Now over here, this 3 to the power of 0, remember, anything to the power of 0 is going to be 1. So I can change that to a 1, but please don't just drop it. Don't just leave it. You need to show that you're changing it to a 1 so that the person who's marking your work knows that you didn't just forget to write it down. They know that you were changing it to a 1. Okay, so it's 1 times, and then over here, when we're taking the root of a power, we divide the exponent of the power by the index of the root. Now remember, you can't see it, but there is an imaginary or an invisible little 2 outside here. Okay, so I'm going to be dividing my exponent by 2. So it's going to be 12 divided by 2, and the base is going to stay the same. So it's still going to be 2, and then 12 divided by 2 is 6. So it's 2 to the power of 6 times, then the same thing I'm going to do over here. The 3 stays the same. I'm going to divide the 20 by 2, and that gives me 10. Okay, so now I've got 3 to the power of 8 times 2 to the power of 4 times 2 cubed all over 1 times 2 to the power of 6 times 3 to the power of 10. Now this 1, I don't have to worry about that anymore. So I can just forget about that because it's not going to change or affect anything. But now I can go and use the first 2 laws, which are for multiplying and dividing powers with the same base. Now remember, when you're multiplying powers with the same base, then you're going to add the exponents. And when you're dividing powers with the same base, you're going to subtract the exponents. But in both cases, the bases are going to stay the same. So I'm looking for things that have the same base first. So first of all, let me go in numerical order from smallest to biggest. So the smallest base is the 2's. Remember, I'm not worrying about the 1, so I'm not going to deal with that. The 2's over here have the smallest base, so I'll do them first. So I've got 2 to the power of 4 times 2 to the power of 3 divided by 2 to the power of 6. They all have the same base. The base is going to stay the same, and I need to deal with the exponent. The 4 and the 3 I'm going to add because they are being multiplied. These 2 powers are being multiplied, so that means I add those. So 4 plus 3 is 7, and if I then divide by 2 to the power of 6, it means I'm going to subtract that 6. So it's going to be 7 minus 6. Now what you can do is you can cancel things out over here. So I can say, okay, 2 to the power of 4 and 2 to the power of 6 I can simplify, and that's going to cancel completely. Remember, whichever one is the smallest one is going to cancel out completely, and the other one is going to have something left. So 2 to the power of 6 is going to have, I'm going to say 6 minus 4, that gives me 2 to the power of 2 at the bottom. So I've cancelled out the 2 to the power of 4 and the 2 to the power of 6. Now I'm left with 2 to the power of 2 at the bottom, and over here I've got 2 to the power of 3. So I'm going to divide the 2 to the power of 3 and the 2 to the power of 2, and that's going to cancel completely, give me 1. And this is going to say I'm going to have 3 minus 2, because remember, when we're dividing powers of the same base, we subtract the exponents. So 3 minus 2 is 1. So it's going to be still 2 to the power of 1, but I don't need to write that one. So over here, from my 2's, I'm just left with 2 to the power of 1, or 2. Now let's have a look at our 3's. So for our 3's over here, I've got 3 to the power of 8 and 3 to the power of 10. There aren't any other 3's, so I can just simplify those ones straight away. So I can say, remember, wherever the biggest one is, that's where I'm going to be left with stuff. The one where the smallest one is, it's all going to cancel out. So the 3 to the power of 8 is going to cancel out completely, giving me 1. 3 to the power of 8 goes into there once. And 3 to the power of 10 divides into, or 3 to the power of 8 divides into 3 to the power of 10. And I'm left with 3 to the power of 10 minus 8 is 2. Okay, so I'm left with 3 to the power of 2. So at the top of my fraction, I have 1 times 2. So it's just 2. And at the bottom of my fraction, I have 1 times 3 squared. Okay, once I've got that, I now look and see, is it reasonable to change this back to normal numbers, or should I leave it in exponential form? When you have numbers that you are able to change back to normal numbers, to write in standard form, not leaving it in exponential form, then you should do that. So over here, 3 squared, that is, it's reasonable to change that to a normal number. Okay, so 2 over 9. 3 squared is the same as 9. So that is how we would leave that answer. If this was, say, 2 over 3 to the power of 10, then I wouldn't change it. I would leave it in exponential form, because it's not reasonable. We don't expect you to know what 3 to the power of 10 is equal to. We do expect you to know what 3 to the power of 2 is equal to. So then you can change that to a 9. Okay, right. Now I said I was going to show you another way of doing the same question. Okay, I'm just going to show you a couple of other things that you can do to deal with some of the things that you have in this question a little bit differently. Okay, so I'm going to start off in the same way. So I've got over here my 3 to the power of 4 times 2 squared, squared times 2 cubed. That is all over my denominator, which is 3 to the power of 8 in brackets to the power of 0 times the square root of 2 cubed times 3 to the power of 5 to the power of 4. Okay, so now that is what the question looks like. Now the top of it, I'm going to deal everything there the same as I did in the first method over here. So nothing's going to change. So I'm still doing 3 to the power of 4 squared is 3 to the power of 8 times 2 squared squared is 2 to the power of 4, and the 2 cubed didn't change. Okay, so none of that is going to be any different here. The differences come in with how I'm dealing with the things in the denominator. So over here, in this method over here, I raised the power to the power, and then I used the power of 0 idea. Okay, so I said 3 to the power of 8 to the power of 0, that is 8 times 0 is 3 to the power of 0, and then I changed it to a 1. Okay, the other way of doing it is to look at this whole thing as a base with a power of 0. And remember, we said anything to the power of 0 is equal to 1. So what I could do here is I could change this to a 1 straight away. I don't need to do this and then change it to a 1. I can change it to a 1 straight away, because I already know it is something to the power of 0. So over here, I can change this to a 1 straight away. Okay, then over here, in this method over here, what I did is I first raised the powers inside to the power outside in the brackets within that square root sign. Another way of doing it is to take the square root and apply it first to this whole thing, treating this whole thing as a power. So ignoring what's inside here and saying it is something to the power of 4 and it's being square rooted. Now our rule is when you are taking the root of a power, you divide the exponent by the root index. Okay, so over here, it doesn't matter what the base, this whole bracket over here is the base of this power. Okay, So it doesn't matter what that stuff is inside. I've got a base with a power, and I've got a root over here. So I can take this power index, or that exponent, and divide it by the root index. So it's going to be 4 divided by 2. And once I've done that, then I will be left with my brackets squared, which I will then have to go and sort out, raising a power to a power over there. So I can do it this way. The reason I can do it in this example, I can't always do it, is because I can divide 4 by 2. Sometimes if you had an odd number here, or if this was a 3, you wouldn't be able to do it. But because this is a multiple of the index of the root index over here, you can do it this way. Okay, so over here, what I'm going to do is I'm going to get rid of my root first, and then I will get rid of my brackets in the next step. So it's just doing it in the opposite order. The benefit of doing it this way, when you can do it this way, is it means you will have smaller numbers to work with because you're dividing first, which means you're making your numbers smaller. Okay, so over here, I'm going to have the square root of a base to the power of 4. So I divide that 4 by the root index, and that gives me that same base. Remember, the base doesn't change. So the base stays 2 cubed times 3 to the power of 5 in brackets. So my base is staying the same, and I'm dividing the exponent by the root index. So it's 4 divided by 2, which gives me 2. Okay, so now I'm going to go and multiply those powers, or raise those powers to the power outside, which is the square. Okay, so now I'm going to have at the top 3 to the power of 8 times 2 to the power of 4 times 2 cubed over. Now I can not worry about that one. I don't have to write it anymore because I've already shown that it's changing to a 1. Now I can just leave it. And so over here I've got 2 cubed squared is 2. Remember, the base doesn't change. And I multiply the exponent. So 3 times 2 gives me 6. Times, and then here 3 doesn't change, and 5 times 2 is 10. So I end up over here with the exact same thing as I had over there. It's just I did it in a slightly different order. Okay, and then we will go and simplify it the same as we did previously. So over here, I'll still have my 2 to the power of 4 and my 2 to the power of 6 cancelling and simplifying. That gives me 2 squared over there. That will simplify with that, giving me 2 at the top. And then over here, I will still have my 3's also cancelling the same way. So I've got, sorry, this is supposed to be 3 to the power of 8. I wrote it incorrectly there. 3 to the power of 8. Okay, so 3 to the power of 8 and 3 to the power of 10. That cancels completely, giving me 1. And this gives me 3 to the power of 2. So I still get the same result of 2 over 3 squared, which I can then simplify to 2 over 9. So you get the same answer. It's just approaching the different steps slightly differently. Okay, now remember, this method is only possible because that exponent was a multiple of the root index. If this exponent isn't a multiple of the root index, you will need to do it the way we did it this one over here. Okay, right. Now let's do another example quickly before I give you some to do for yourself. In this example, we have got in brackets 2 cubed times 5 squared, and that's all being squared, and that is all over 10 squared. Okay, now what you might notice in this example is that we've got no bases that are the same. Okay, so I'm going to start off by sorting out this over here, but then in order for me to finish simplifying this, I need to have powers with the same bases. Otherwise I can't do any multiplying or dividing to simplify it further. So I'm going to show you what we're going to do for that. Okay, so let's have a look at this example. Okay, so here I've got my question. So the first thing I'm going to do is deal with these brackets over here where I've got 2 cubed times 5 squared, and that's all being squared. So remember, we've got a product inside here, so I need to do each of the factors and raise it to the power outside. So I'm going to have 2 cubed squared is 2 to the power of 3 times 2 is 6. Remember, the base stays the same, so it stays 2, and we multiply the exponents. Then I've got times 5 squared squared. Again, the base is going to stay the same, so it's going to be 5. And the 2 and the 2 I'm going to multiply together, so that gives me 4. Okay, then that is over. Now over here I've got a slight problem, because if I just write 10 squared, I'm not going to be able to do anything else, because the only other thing I'll be able to do is dividing and multiplying and Nothing here has the same base. And in order to use the laws of exponents, I have to have powers with the same base. So that means I need to do what I can do over here to make sure I have the same base. So if you look at the number 10, it can be written in terms of 2 and 5. 10 is the same as 2 times 5. So what you need to learn how to do now is when you have bases that are not the same as other bases, if they can be changed to be the same as other bases, by writing them as products of their prime factors or products of the other bases in any way, we don't want to have pluses and minuses. We want to have multiplication when we are changing this over here. So we're going to say that 10 is the same as 2 times 5. And if I can do that, I will then be able to continue using the laws of exponents to help me to simplify this. So the 10 is the same as 2 times 5. So I want to be able to, if I have a base that doesn't fit in with the other bases, but it's not a prime number and the other bases are prime numbers, you can see if you can make it fit in with the other bases by changing it to a product of its prime factors. Okay, so over here, 10 is the same as 2 times 5. So this is 2 times 5. I put that in brackets because I'm changing the 10, and the whole 10 is to the power of 2. So the 2 goes outside the brackets over here. Okay, so it's 10, which is 2 times 5, to the power of 2. That's the same as this over here. And now we're going to go and use what we already know about our laws of exponents, which says if I've got a product being raised to a power, I'm going to give that power to each of the factors. So I have 2 to the power of 6 times 5 to the power of 4 over, now this is the same as 2 to the power of 2 times 5 to the power of 2. And now I can go and simplify this because now I've got the same bases. So over here, I've got my 2's, and here I've got my 5's, and I can simplify those, and I can say, so 2 to the power of 6 divided by 2 to the power of 2. Remember, when we are dividing, the answer is going to go wherever the higher exponent is. So I've got the higher exponent in my numerator. So I'm going to have 2 to the power of 6 divided by 2 to the power of 2 is going to be 2 to the power of 6 minus 2 is 4. So the base stays the same. It's still 2, and it's to the power of 4. And over here, 2 to the power of 2 divided by 2 to the power of 2 cancels, giving me 1. Okay, then over here I've got 5 to the power of 4 and 5 to the power of 2. That, again, the higher one is at the top. So it's going to be 5 to the power of 4 minus 2 is 2. And at the bottom, it cancels, giving me 1. So now what I'm left with at the top of my fraction is 2 to the power of 4 times 5 to the power of 2. And at the bottom of the fraction, I'm left with 1 times 1. And when you only have 1 in your denominator, you don't need to write it. So I can stop writing it as a fraction now. I can just leave it as 2 to the power of 4 times 5 to the power of 2 at the top of my fraction without having to worry about writing the bottom of my fraction. Now we need to look and see, is it reasonable to change this to standard form instead of writing it in exponential form? So 2 to the power of 4 is a reasonable number to change. You should know that 2 to the power of 4 is the same as 16. Okay? And 5 to the power of 2 is also reasonable. You should know that 5 squared is the same as 25. So now we've got 16 times 25. Okay, so now this you need to be able to work out. So we're going to work this out, and that should give you 400. So the answer for that question is 400. Okay, so now I'm going to give you a few that you're going to do for yourself. In the first question you've got over here, negative 5 in brackets squared times 2 cubed times 5 in brackets cubed, and that's all over 2 to the power of 5. Now you need to use the laws of exponents to help you to simplify this and write it in the simplest form that you can, leaving an exponential form if necessary. Okay, so I'm going to give you 1 minute to work on this question. Okay, so let's go through that question and see what you should have got. So first of all, I'm going to deal with the -5 squared. Now remember, when you are squaring a negative number, or when you're taking a negative number and raising it to any even power, then we are going to have it change to positive, okay? Anytime you have an even exponent with a negative number, you're going to end up with a positive result. So that's going to change to positive, so it's just 5 squared. Okay, then I have times. Over here, I need to get rid of these brackets as well. So I'm going to take the 2 cubed and raise that to the power of 3. That gives me 2 to the power of 9. Remember, your base stays the same, and you multiply the exponent. So the 2 stays 2, and we multiply 3 times 3 is 9. Times 5 to the power of 3 is going to be over here 5 cubed. Okay, and that goes over 2 to the power of 5. Okay, so now I've reached the point where I can go and do my division and multiplication. So let's look at our 2's first. So for our 2's, I've got over here 2 to the power of 9 and 2 to the power of 5. So this, the higher one is at the top, so the answer or the result is going to be at the top. If I say I'm dividing, so I'm going to be subtracting my exponents. 9 minus 5, that gives me 4. So it's 2 to the power of 4 at the top, and that cancels and gives me 1 at the bottom. Then I also need to look at my 5. So I've got over here 5 squared and 5 cubed. If I multiply them together, the base is going to stay the same, but I need to add the exponent. So it's going to be 5 times, or 5 to the power of 2 plus 3, which is 5. Okay, and that's going to give me 2 to the power of 4 times 5 to the power of 5. Now this, because the 5 to the power of 5 is quite high, you don't need to change that. You can change the 2 to the power of 4, and that'll give you 16 times 5 to the power of 5, but you don't necessarily have to because you're not changing the 5 to the power of 5. Okay, so you can leave it as either of those. Right, now let's go on to the next question. In question B, we've got, in brackets, 2 squared cubed over 2 to the power of 7, and all of that is in bigger brackets squared. Okay, so now I'm going to give you 1 minute to work on this question. Okay, so let's go through that question and see what you should have got. So over here, I've got, inside my big brackets, I've got a fraction which has at the top 2 squared in brackets cubed, and at the bottom 2 to the power of 7, and outside the big brackets, I'm squaring it all. Okay, so first of all, let's go and simplify what's inside here. So this is all going to stay as it is, like that, with a square outside, and I'm going to simplify that. So I've got 2 to the power of 2 in brackets cubed. So the 2 is going to stay the same, and I'm going to multiply the exponent inside and outside. So 2 times 3 is 6. And that goes over 2 to the power of 7, which isn't going to change yet. Okay, so now I've simplified the brackets inside. Now I'm going to go and simplify the fraction inside those brackets over there. So 2 to the power of 6 over 2 to the power of 7, when I am simplifying this, remember the answer is going to go where the higher exponent is. So the 2 to the power of 6 is going to cancel out completely, giving me 1. And the 2 to the power of 7 is going to cancel out, giving me 2 to the power of, and then 7 minus 6 is 1. Now I don't need to write that 1 because 2 to the power of 1 is the same as just 2. So that's 1 over 2. Now when you are when you end up with a fraction where the numerator is 1, you have to write that. You can't just write 2. You have to write 1 over 2. So it's not like if I had ended up with a 1 at the denominator, then I wouldn't have to write the fraction anymore. When the numerator is the 1, you have to still write the fraction. So it's 1 over 2, and that is being squared. Okay, once we've got to this point, now we need to go and use the rule that we have for raising a product to a power, or you can also think of it as taking a common fraction and finding the square of that common fraction. You have to do it like with a product. You do it to each factor. If you've got a fraction, you do it to the top and to the bottom. Okay, so the numerator and the denominator both get that exponent. So it's going to be 1 squared, which is just 1, over 2 squared, which you can straight away write as 1 over 4 if you want, or you can write 1 over 2 squared and then write 1 over 4. It doesn't really matter. You could have gone straight to 1 over 4, but that is what you should have ended up with. You shouldn't leave it as 1 over 2 squared, because 2 squared is reasonable to change to 4, so we do expect you to do that. Okay, right, so that's question B. Now let's go on to question C. In question C, you have got, again, a fraction, and at the top of the fraction this time you've got a square root, and inside the square root you've got, in brackets, 5 squared times 3 to the power of 4, and that's all being cubed. And then at the bottom of the fraction you've got 15 squared. Okay, now this one's going to be a little bit more tricky to do, so I'm going to give you 2 minutes to work on it. Okay, so let's go through that question and see what you should have got. So first thing I'm going to do over here is I look and see my root index is a 2. The power of the brackets outside, the exponent outside the brackets, is a 3. 3 is not a multiple of 2. So that option that I showed you in that other example earlier is not an option in this one. I can't divide the 3 by the 2 and get a whole number. So that means I'm not going to be able to first get rid of my square root and then get rid of my brackets. So I'm going to have to first get rid of my brackets inside and then take the square root of it. Okay, so I'm going to do that. So I'm going to start off. My square root is going to stay as it is. I can't get rid of it yet because I first have to sort out the brackets inside. Okay, so over here I've got 5 squared, which I'm going to cube. That gives me 5 to the power of 2 times 3 is 6. Times, then I've got 3 to the power of 4 cubed, and that gives me 3 to the power of 4 times 3, which is 12. Remember, the bases stay the same, and we multiply the exponents with the exponent outside. Okay, so then I have at the bottom of my fraction 15 squared. Now, if you look at the 15 squared, you should be able to see straight away you're going to have a bit of a problem here, just like we had in the example I did with you earlier, where we had the 2 and 5 and 10, and none of them had the same basis. If you look over here, 5 and 3 and 15, again, none of them have the same basis. So what I'm going to do now already is I'm going to say, I know that I'm going to need 3s and 5s. 15 is the same as 3 times 5, so I'm going to change the 15 to 3 times 5, so that I'll be able to simplify further once I have sorted out that root over there. Okay, so I've got 3 times 5, and that is the power of 2. Remember, the 3 times 5 has to go in brackets, and the exponent needs to go outside the brackets. Okay, now we're going to go and get rid of our square roots over here. When you take the square root, you're going to divide the exponents by the root index. So it's going to be 6 divided by 2, and that gives me 5. The base stays the same. To the power of 6 divided by 2 is 3. Times 3 to the power of 12, so it's 12 divided by 2 is 6, so it's 3 to the power of 6. Just like when we are raising a product to a power, we do it to each of the factors. The same thing applies when you're finding the root of a product as well. You do it to each of the factors. Okay, so now at the bottom, I'm going to get rid of those brackets as well. So I've got 3 with a power of 1, and that's being squared. So it's 1 times 2, that gives me 2. So it's 3 to the power of 2 times 5 to the power of 1 squared is 5 to the power of 2. Okay, so that's what you should have got up to that point. Now we need to go and simplify it by looking at the things that have the same basis. The powers are the same basis. So I'm going to look at my 3s. Over here I've got 3 to the power of 6, and here I've got 3 to the power of 2. The one with the higher exponent is in the numerator, so that's where my answer for the 3s is going to be. So I'm going to have over here 3 to the power of, and then 6 minus 2 is 4. And at the bottom, that cancels out completely. Then for my 5s, I've got 5 cubed and 5 squared. Again, the higher one is at the top, so that's where my answer is going to be. I'm going to have 5 to the power of 3 minus 2 is 1, or just 5, and that cancels out completely, giving me 1. Okay, so now at the top of my fraction, I'm left with 5 times 3 to the power of 4, or 3 to the power of 4 times 5, if I write them from smallest to biggest with their bases. And at the bottom of our fraction, I've got 1 times 1. Now, because it's in the denominator, I don't need to write that. I can just leave it as 3 to the power of 4 times 5. Okay, and this one over here, 3 to the power of 4 is quite a big number. You don't need to really change that. Okay, so now we're going to go on to the last question for today. In question D, you have got 8 squared times 5 in the numerator of your fraction, and in the denominator, you've got the cube root of 2 to the power of 12 times 5 to the power of 0. I'm going to give you 2 minutes for this question as well. Okay, so let's go through that question and see what you should have got. Okay, so over here I've got 8 squared times 5. Now the very first thing you should see when you have a question like this, as soon as you see a power where the base is not a prime number, you need to check all of the other bases in your question and see if that same base appears anywhere else. And if it doesn't, you're going to need to change it and try and make it fit in with the other bases you've got. So over here, 8 doesn't fit in with a 2 and a 5 and a 5. I'm not going to be able to simplify 8 with anything else here unless I change it to 2 cubed, because 8 is the same as 2 cubed. Okay, so I'm going to change 8 to 2 cubed, writing it as a product of its prime factors. And that is squared. Now, if you had a question, sorry, it's times 5. If you had a question where, say you have 6 to the power of 2 and 6 to the power of 3 and 6 to the power of 5 in the question, then you don't need to change the 6 to 2 times 3 because you've got all of the things with 6's. So you can keep it as 6. But if you've got a 6 and a 2 and a 3, then you need to change the 6 to 2 times 3. Over here, if I had other 8's, I could leave the 8 as 8. But because I don't have other 8's, I need to change that 8 to a product of its prime factors, which is 2 cubed. Okay, and this is over the cube root of 2 to the power of 12 times 5 to the power of 0. But I have two choices of how I can do this over here. I can take the cube root of this and do the cube root of that and then simplify, or and then change the 5 to the power of 0 to a 1. What I can also do is I can first sort out this 5 to the power of 0 and then take the cube root. So you can choose which way you want to do it. I'm going to be taking the cube, or I'm going to be changing that to a 1 first, and then I'll change the cube root. Okay, so I'm going to keep this over here as the cube root of 2 to the power of 12, and that is going to be multiplied by 1, because 5 to the power of 0 is the same as 1. I'm changing that first, but you could have done it in the opposite order, okay? It doesn't really matter. So now I've got 2 cubed squared, and that gives me 2 to the power of 3 times 2 is 6, multiplied by 5. So in my numerator, I've got 2 to the power of 6 times 5, over, in my denominator, I've got the cube root of 2 to the power of 12. That gives me 2 to the power of 12 divided by 3 is 4. So the base is the same, and I divide my exponent with the root index. And then the 1, I don't have to worry about anymore, because the cube root of 1 is still 1, and if I'm just multiplying by 1 anyway, it doesn't actually do anything. Right, so now I can go on and simplify further. So I've got 2 to the power of 6 and 2 to the power of 4, which I can simplify. If I cancel these out, the higher one is at the top, so the answer is going to go at the top. So I've got 2 to the power of 6 minus 4 gives me 2 to the power of 2. And at the bottom, I've got 2 to the power of 4 divided by itself is 1. Okay, so 2 to the power of 2 at the top and 1 at the bottom. And over here, the 5 isn't going to be able to cancel with anything. So that gives me 2 squared times 5, and at the bottom I just have a 1. So again, if your 1 is in the denominator, you don't have to write it. So this I can simplify further, because remember, you only leave it in exponential form if it's not reasonable to change it to standard form. So over here, this is reasonable to change to standard form. 2 squared I can write as 4 times 5, and 4 times 5 is the same as 20. So for that question, you should have got 20. And that is how we use the laws of exponents. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.